In previous examples, we've seen applications of Taylor's inequality to estimate errors. But if we have an alternating series, then we can use the alternating series estimation theorem as well. And that's what we're going to do to estimate the range of values of x, for which the cosine of x is approximated by 1 minus x squared over 2 plus x to the fourth over 24 is valid for an error less than 0.005. Let's recall what the alternating series estimation theorem says. Essentially, if we have a series of sigma negative 1 to the n minus 1 times b sub n, where b sub n's are positive and we have that the series is decreasing and the limit is 0, so it passes the alternating series test, then the remainder is less than or equal to the first neglected term. So here what we have is the cosine of x is being approximated by 3 terms, and the first neglected term would then be x to the 6th over 6 factorial. In other words, for the cosine of x, we have that b sub 3 is equal to x to the 6th over 6 factorial. And the reason it's b sub 3 and not 4 for the fourth term is that we start our counting at 0. Remember, we have the 0th term, the first term, and then n equals 2. So here we're looking at b sub 3. That's where n equals 3. So because we wanted our accuracy or our error to be less than 5 thousandths, we're looking at x to the 6th over 720, that's our 6 factorial, is less than 5 thousandths. Which would mean by clearing the fraction, we have x to the 6th is less than 0.36. Taking the 6th root of both sides is going to give us that the absolute value of x is less than approximately 0.84. We did take an even root on both sides, and that's why the absolute value. That will give us an interval for x of approximately negative 0.84 to approximately 0.84, and that answers the question. Now, how big is this, you ask? 84 hundredths is approximately 48 degrees. So this is a range of approximately negative 48 degrees to approximately 48 degrees. And so in terms of the unit circle, we're talking about a range that's pretty good in size, approximately negative 48 degrees to approximately 48 degrees. And so just 3 terms of the cosine expansion is sufficient to be accurate to within 5 thousandths for this entire portion of the unit circle. Looking at the text, we can see that physicists often consider only the first 2 or 3 terms in Taylor's series because of kind of what we just saw, which is the first 2 or 3 terms tend to be accurate enough for a lot of work that folks do. And I had a computation error. I said that 720 times 0.005 was 0.36. It actually is 3.6, and the 6th root of that is approximately 1.238. So the interval that I stated should reference that number, approximately negative 1.238 to 1.238, and in degrees, that is approximately 71.